Welcome to Understand the Math. In this question, we're going to use Gauss-Jordan elimination to find the general solution of the following linear system of equations. The first step that we're going to do is we're going to take our linear system of equations and we're going to put it into an augmented matrix. So our augmented matrix looks like this. And our right-hand side is 8, 1, 10. To do Gauss-Jordan elimination, we're going to work down and to the right. So the first thing that we're going to do is circle our first pivot. And then I'm going to highlight the entries below that pivot because those are the entries that we have to set equal to 0. So the row operations that we're going to use to get rid of the -1 is we're going to take row 2 and we're going to replace it with row 2 plus row 1. And then to get rid of the 3, we're going to take row 3 and we're going to replace it with row 3 minus 3 times row 1. Let's go ahead and do that. Our first row is not going to change, so we'll go ahead and we'll write that down. Now our second row, we're going to take row 1 and add it to that second row, so we get a 0, a -1, a 5, and a 9. And then in the third row, we're going to get rid of the 3, and we're going to take -3 times row 1 and add it to row 3. And that's going to give us a 0, a -10, a -2, and then a -14. We're now going to work down and to the right, and we're going to circle our next pivot, and then we're going to get a 0 below that pivot. To do that, we're going to take row 3 and we're going to replace it with row 3 minus 10 times row 2. This is going to give us the following matrix. Our first two rows are going to stay the same, so we'll go ahead and write those down. And then our second row is going to change. We're going to take row 2, multiply it by -10, and add it to row 3. And this gives us a 0, and then we get a -50, -2. So we have a -52. And then we have a -90, -14, gives us a -104. Now we're going to continue to work down and to the right. So we're going to circle our pivot. At this stage, we're going to start the backward algorithm where we need to make sure that every pivot is equal to 1. So what we're going to do is we're going to take row 3 and we're going to replace it with row 3 divided by -52. Here's what we get. Our first two rows are going to be the same. And then our second row, we're going to divide by -52, so we get a 0, 0, 1. And then it's nice that 52 goes into 104 2 times, so we get a 2 on our right-hand side. Now what we're going to do is we're going to work up and to the left. That's called the backward phase of our algorithm. And what I'm going to do, I'm going to highlight now in blue the entries that we have to make equal to 0. So let's go ahead and let's write down these row operations. We're going to take row 2 and we're going to replace it with row 2 minus 5 times row 3. And then we're going to take row 1 and we're going to replace it with row 1 minus 2 times row 3. Let's go ahead and let's do that. When you do the backward phase of the algorithm, I know it seems awkward, but you want to write down the last row first because what we're doing is we're holding the last row fixed and we're changing the rows above it. So our second row, we're going to get by multiplying row 3 by -5 and adding it to row 2. So we have a 0, a -1, a 0, and then we pick up a -1. Now we're going to change row 1. We're going to multiply row 3 by -2 and add it to row 1. And this gives us a 1, 1. We get a 0. And then on the right-hand side, we're going to get a -4 plus 8 gives us a 4. We're almost done. Now what we're going to do is we're going to work up and to the left. So the next pivot that we're going to circle is this one. We need that pivot to be equal to +1. So what we're going to do is we're going to take row 2 and we're going to replace it with row 2 divided by -1. Our bottom row is the same, 0, 0, 1, and then we have a 2 on the right. Our second row, we're going to multiply by -1. So we get a 0, 1, 0, and a 1 on the right-hand side. And then our first row stays the same. Now we're going to circle our pivot again. It's equal to 1, so that's great. Let's go ahead and let's highlight the entry above it that we need to make equal to 0. So to make this entry to 0, what we're going to do is we're going to replace row 1 with row 1 minus row 2. Give ourselves a little bit more space here. So our last row and our middle row are going to stay the same. You'll get used to writing these rows in this order. And now our top row is going to change. We're going to multiply row 2 by -1 and add it to row 1. And we get a 1, 0, 0. And then a 4 minus 1 is equal to 3. Now we have our answer in reduced echelon form. We're going to go ahead and we're going to circle our pivots. And then we're going to solve for those pivot variables. Let's look back up here at the top. Our variables were x1, x2, and x3. So we can read off going across the first row, we have x1 is equal to 3. Across the second row, we get x2 is 1. And then across the third row, we get x3 is equal to 2. The really nice built-in check that we can do is we can take these answers and we can go back up to the top, plug them in, and make sure it's right. So let's go ahead and put this in our head. We have 3, 1, 2. So what we're going to do is we're going to say, okay, so x1 is 3, plus x2 is 1, plus 2 times 2 is 4 is equal to 8. That works. And then we're going to have minus 3, minus 2, plus 6 is equal to 1. That checks out. And then lastly, we're going to have 9 minus 7 plus 8 is equal to 10. And our left-hand side is equal to our right-hand side. So that way we know that when we got all the way through that complicated algorithm, we came up with the right solutions.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.